Hello, this is Mr. Waterman. This is Precalculus 9.3 Hyperbolas. This is the fourth and final conic section that we're going to be dealing with in this chapter. And so, definition of a hyperbola is the set of all points, x, y, in a plane. The difference of the distances from two fixed points is a positive constant. Okay, so with an ellipse, the sum of the differences of the distances, d1 and d2, was a constant. This time it's the difference, d2 minus d1 is a constant. So you end up with this shape that has two branches. Alright, these are called branches. We have, when it opens up and down, the transverse axis is said to be vertical. Okay. And the center is the midpoint of this transverse axis. It goes vertex to vertex between the two branches. And lastly, the foci are up here kind of inside the dishes, above and below on this one that has branches that open up and down. And so, a couple definitions. A is the distance from the center to each vertex, and C is the distance from the center to each vertice. So our equations are x squared over a squared minus y squared over b squared is 1, and that's if the transverse axis is horizontal. So whichever one is first, so on this one, x squared comes first and is the positive term, and then we have minus y squared over b squared. If x comes first, that means the transverse axis is the same, goes in the same direction as the x-axis. And then if y squared comes first, that's the positive term, minus x squared, then the transverse axis is in the same direction as the y-axis, like in our little illustration above. Okay, so example-wise, we want to find the center, vertices, and foci of the equation 4y squared minus 9x squared equals 36. So first step is to take this and to put it into standard form, make the right side equal to 1. So we're going to divide everything by 36. I end up with y squared over 9 minus x squared over 4 equals 1. And then from the equation above, we see that this is our standard form that we're going to use because y squared comes first on this one. So that means the transverse axis is vertical. So therefore a comes underneath the first term, whether it's x squared or y squared. And so a squared is 9, which means a is 3. And then b squared is 4, which means b is 2. So unlike ellipses, c squared is now a squared plus b squared. Alright, so this one, the hyperbola has a subtraction sign between the y squared and x squared terms in its equation, but the equation for finding c squared is simply a squared plus b squared. Looks a lot like our friend the Pythagorean theorem. So we just simply substitute in a squared and b squared here, and we're going to get c squared equals 9 plus 4, which is 13. So what that means is c is going to be the square root of 13. Okay, so using the definitions we listed above on our diagram, we can now answer the questions. So first of all, our center is going to be at 0, 0, which is true for any of these. If there's nothing subtracted from y or x on the top of these, and we'll see that form on the next page, then the center is assumed to be at the origin. And then vertices are going to be, so we already said that this is, the transverse axis is vertical, so our vertices are at plus and minus. So the vertices are a, the distance a above and below the center. So we're going to write 0, comma, plus or minus a, and a equals 3. So 0, comma 3 and 0, comma negative 3 are where our vertices are. And lastly, our foci are also at 0, comma, and now we're going to go plus and minus c from our center, and we found c to be the square root of 13. So that's between 3 and 4, the square root of 13 is. So just a little bit above here will be our foci. Okay, another example, find the standard form of the equation of the hyperbola centered at the origin with a transverse axis of length 4 and foci at plus and minus 3, comma 0. So now we have, so we're going to have a center at 0, 0, because they gave us that, it says origin. Transverse axis length 4, foci at plus and minus 3, comma 0. So 1, 2, 3, 3, comma 0, that's a focus, and negative 3, comma 0, also a focus. So we now know that this has a transverse, a horizontal transverse axis. And they said the length is 4. What that means is our foci are going to be at plus and minus 2. And, whoops, I'm crossing my terms up, I'm sorry. So here we go. Let's go back. At 3, those are our foci. At 0, plus and minus 3, comma 0. Then, at 0, comma 2, so it says the length of the transverse axis is 4. That's from vertex to vertex. Alright? So this overall length of the transverse axis is always 2a in length. Okay, we have a over here, negative a over here. So a then, if it has a length of 4, a must equal 2, and c must equal 3, the distance from the center to the focus. So now we can go ahead and solve for for b, excuse me. So we're going to use c squared equals a squared plus b squared. Typically they're going to give you 2 of these values, a, b, or c. So this time we're starting with c. So we're going to substitute in c squared minus a squared is going to equal b squared. So c squared is 9, a squared is going to be 4, and we're going to end up with b squared equal to 5. So b equals square root of 5. So let's see, what do they want us to do? Find the standard form of the equation. So we said this has a horizontal transverse axis. We're going to use Oh, but the center isn't at h comma k, the center is at 0, 0. So we're going to use this form here, x squared over a squared. Alright, so x squared over a squared. We were given that a is 2, so a squared is 4. Alright, so x squared over 4 minus y squared over b squared. B squared's 5. We just solved that right here. And then this is going to equal 1. So that's our equation. Might be a good idea if you're doing this as an assignment to check that on your graphing calculator. All right.